All right, so today we are looking at vertical stretches. All right, vertical stretches. So, and we're going to be looking at vertical stretches for quadratic parent functions. So, if we have y equals ax squared or f of x equals ax squared, all right. Now, remember when we're talking about a quadratic parent function, one or a is equal to one because then we'll have y equals x squared, okay, or f of x is equal to x squared. There's an invisible one in front of that x, okay? A vertical stretch is when a is greater than one, the graph will get skinny and tall, okay? So that means if a is greater than one. So if we look at this table here, we have f of x equals x squared, which is this is the parent function. This first or the middle table, this is the parent. All right, and then g of x equals 2x squared is the child function. If you can look and see that there is an invisible one in front of the x squared, but in front of the x squared for the parent function, we have a 2. So that means when a is going to be greater than 1, the graph will get skinnier and taller, which creates a vertical stretch. So we can say that when a is greater than 1, right, you either multiply the parent function by a factor of 2 or you just multiplied it by 2. All right, so we'll get into that after we go ahead and graph it. So how do I find my numbers, right? So I have x squared, and these are the values of x that I'm going to substitute for x squared. So that means we're going to have f of x is equal to negative 2 squared, which is equal to positive 4. We have f of x is equal to negative 1 squared, which is equal to 1. F of x is equal to 0 squared, which is equal to 0. And we would keep going until we've completed all of our rows. So f of x is 1 squared, which is 1. And f of x is equal to 2 squared, which is equal to positive 4. All right, so if we know that this is what f of x equals, and we know that our parent our child function is 2x squared, then that means I am going to multiply 2. I'm going to multiply 2 to each one of my terms. All right, because that's where that 2 comes from. So 4 times 2 is going to give me 8. 1 times 2 is going to give me 2. 0 times 2 is going to give me 0. And 1 times 2 is 2. And 4 times 2 is 8. All right. Now, let's go ahead and graph our parent function. Our parent function ordered pairs are going to be as follows. So it's going to be negative 2 comma 4, negative 1 comma 1, 0 comma 0, 1 comma 1, and 2 comma 4. All right. And I got those numbers by pairing the x and the f of x, the ones that I'm circling. Okay. So let's go ahead and graph that. So negative 2, I'm going to go up to 4, negative 1 to 1, and then 0 to 0, positive 1 comma 1, and then positive 2 comma 4. All right. And remember, I have to trace it as or sketch it as beautiful as I can. Now um, let's look at our child's function. Sorry, I didn't mean to erase that. All right, so our child function ordered pairs are going to be negative 2 comma 8, negative 1 comma 2, 0 comma 0, 1 comma 2, and 2 comma 8. And I got those from saying the x values and the g of x. All right, so negative 2 comma 8. We have negative 1 comma 1. I'm sorry, negative 1 comma 2. We have 0 comma 0. We have 1 comma 2. And we have 2 comma 8. And as you can see, this graph is slightly skinnier than the parent function. So remember, when a is greater than 1, the graph will get skinnier and taller, okay? It gets skinnier and taller.